Hi, sorry for a little late for this chapter 2 lecture, but I took the weekend off. So this week chapter 2 is static routing. So we'll talk about why do I need static routing. So remember that a router routes one of two ways, either manually, or you manually assign it, or dynamically based on a dynamic routing protocol. We'll talk about dynamic routing protocols a little bit later, but today we're going to worry about the manual, setting up a manual route, a static route. Now, why would I want to use static routing? Well, static routes, one, they're not advertised, so they offer, to other routing protocols, so it's definitely allows better security. They definitely use less bandwidth, so they don't take up less CPU, so they're a little bit faster. And then, path to a static route can be used to send, you want to make sure that that route is always up. A print server, a file server, an email server. You want to make sure those are always up. You don't have a dynamic address on those where the address have a chance of changing. Pros and cons. Configuration on a static route is definitely, as the network gets bigger, it becomes harder and harder to maintain those routes. So of course, as the topology changes, it becomes an issue. It's not very scalable. It's definitely more secure. Definitely uses less resources. And of course, the predictable, it's static route is always there. So there are some benefits, but once your network gets about the size over 5, you're probably better off staying away from static route, except for an extreme case. And we'll talk about some of that a little bit later. So when do I want to use it? Well, when is, I want to ease maintaining the routing table. So on a smaller network, it's easy to use. If I'm going to go to a stub network, and a stub network is one, as you can see this picture here, there's no other network outside of this. So router 2 connects to router 1, and router 1 goes nowhere. So that makes it a stub. So it makes it very easy for router 2 to say, I'm going to set up a stub network, static address here, so I don't have to waste a lot of resources here searching through routing tables to find a match. So that's not bad. And then a single default route can represent a path to many networks. So if there had been several networks under router 1, you could set up just one static address to cover all of these. I think you'll see an example here a little bit later. Applications, I want to connect to a specific network. I want to make a gateway of last resort. So if I don't know all the routes, I just want to pass this on to the next router that may know. A good case. Reduce the number of advertised networks, and if a route fails, it's a good backup. So a standard static route, I just want to specify, from router 2's perspective, I'm going to specify just the address to the stub network. So I would identify, address 172.16.3.0, and of course, subnet mask 255.255.255.0. That's what that /24 represents, remember? So that way I can just get to that. Now, again, the default static route says, hey, I don't really know this address, and I want to make sure all my addresses are 0. So I'll identify a route that has 0.0.0.0, and then a 0 subnet mask. That would be a default static route, and we'll show you a little bit later as to how you know if it's a default static route or just a standard static route. And then you can summarize. So if I wanted to identify, in this case, router 1 says, gee, I want to specify, I've got 4 networks underneath that's connected to me. Can I summarize these and say, I'll advertise only 1 address versus 4? So I can summarize these addresses into a single address, define a static route, and I get access to all 4 of this. You may see this on a Cisco exam, at least as far as route summarization. I'm not sure you'll see it in this chapter, but a static route is good for it. And a floating static route is what happens if my static route or my network fails and I want to back up. So then you can specify, in case of emergency, I want to define the best way out. And we'll show you a little bit how to do that. So how do we do that? So the command to use is the IP route command. IP route specifies a network address, and this network address, remember, is the destination network. So it's a network I want to go to. So it's a destination network where I'm going and its subnet mask. And then you have several different options. I can specify an IP address, and that IP address is the next hop. So it's the next router's IP interface, or it could be the exit interface. So it could be the exit interface from my router. In which interface am I going to this destination network address? So keep in mind, it's the destination network address. It needs a subnet mask. Then I can specify the IP address of the destination router interface or the exit interface of the existing router. And then if I'm creating myself a floating static route as a backup, then I can specify the administrative distance, and you want to be a little bit greater than the administrative distance for a static route, which is always 1, because what? Administrative distance is the reliability of that address, and if static address has reliability of 1 because you set it. So if you want to create a backup, you want to make it like maybe 5, so that it's worse than the static route, but a little bit better than any of the dynamic routing protocols. Now your next hop options, there are, like I said, there's 2 different options. I can do the next hop, which is the IP address of the, of the next router, the destination router. I can do the exit interface, or I can do a fully specified static route, which means I'm specifying both of these. Now, my current version of Packet Tracer, I don't think allows you to do the fully specified static route, but that doesn't mean you won't see it on a Cisco exam. So fully specified means I'm specifying both the next hop, so I'm specifying the IP address of the destination router, or the next router, and it's the next hop, or the interface. You're specifying both for fully static, the exit interface. So let's look at an example here. So I'm looking from a router 1 perspective. So from router 1, which networks don't I know about? I'm directly connected to the 72.16.3 and 172.16.2 networks. This network and this network are directly connected to router 1. So I don't know about 172.16, I don't know about 192.68.1, and I don't know about 198.68.2. So you need to specify static routes for the ones you don't know. So I'm specifying my destination for the 172.16.1 network. I've got to specify the network address, the subnet mask, and in this case, I'm specifying the next hop. So I'm specifying the interface of this router. So I'm going to 172.16.2.2. That's the IP address of the interface of router 2. So I'm getting to exit 1, same thing, 192.168.1.0/24. My interface, the next hop interface, is still that 1, and the same thing for the 192.168.2, the same address, because I only have one exit interface out of router 1. Now, if I wanted to specify just the exit interface, so now it's still trying to define the same 3 networks, but now I'm only specifying the interface of S000 because that's this interface. Now, this is usually a better way because I don't always know the IP address of my next hop. So more than likely, I'm going to do a what can I control? Because I'm the administrator of my network, and once I get on a serial network, I may not have control of router 2 and router 3. So I want to make sure I specify what I can control, and that would be the exit interface. And I don't worry about the IP address of an external network. Now, also, this one says fully specified, but their example does not show both. But if I was fully specified, I would show the exit interface like it shows here, and the IP address of 172.16.2.2 would make it a fully qualified, fully specified address. Now, how do I verify this? Well, show IP route command shows exactly what the status is. Now you'll see, let's see if I can zoom in just a touch on this a little bit. And you see that anything with an S tells me it's static. So that if you wanted to show IP route, and you can be very creative and say, if you got a large network, I can just show me all the static routes by using the keyword static. Now, sometimes Packet Tracer allows you to pipe, that's that upward arrow, to kind of reduce the amount of data you have to look through if your routing tables are fairly large. You can do a specific network. Show me what the IP route is. What does it take to get to that network? Or you can show a running configuration. All of those are valid ways of verifying what the static route is. Now, how do I set a default static route? A default static route, like I said before, is the IP address, so it's IP route. IP address is all zeros. Subnet mask is all zeros. And I still have the same two configurations that I can specify, either the next hop address or the exit interface. 9 out of 10s, if I don't know, if I'm trying to specify that, I want to make sure I just do it in my exit interface because I can control that. Now, here's an example. All it is I'm at router 1, and I'm specifying, in this case, they're specifying the next hop. I would have done the, exit interface, but that's okay. Now, verifying it, show IP route, showing the static command, and now with the default static route, there's two ways you're going to see. One at the top of that, you're going to see gateway of last resort for a given network is 000, and you're going to see this asterisk differently. If you remember the other static route, IP route commands, you saw just an S and the information. Well, if it's a default static route, you will see two indications, gateway of last resort and the static route with the asterisk. How do I test this? Well, guess what? You can, the floating one. And all the floating one is all I'm going to do is specify when I'm defining it, like this example here, I put a 5, I put an administrative distance after that configuration, and that says, hey, normally I want to go to 172.16.2.2, but if that network's down, go to 10.10.10.2. So it's giving you a choice, and that administrative distance there helps you verify it. So let's see, how do I verify things? Well, troubleshooting commands for this are definitely my ping command, trace route, show IP route, show IP interface brief are good commands. And you can do show CDP neighbors detail, which actually says, show me all information about the neighbors that are connected to me. More than likely, we're going to do a ping command, and the show IP route commands would probably be your big keys, but these commands will help you. So hopefully this helps you a little bit as far as static routes, what they're used for, and why you'd want to use them. If you have any questions, you know how to get a hold of me. Have a nice day. Bye-bye.